Hey kiddies, so we are still in our Unit 5 packet, Polynomials and Factoring. Today we are on page 16. We're looking at a new factoring method, our second factoring method, which is difference of two perfect squares, or abbreviation for it would be dots. So if we're looking at today's vocabulary, it talks about how to factor using dots. To use a dots factoring method, the expression that we are factoring must satisfy the checklist below. So both of the terms need to be two perfect square terms, and the operation between them needs to be subtraction. So those are the requirements in order for you to be able to use the factoring method, dots, difference of two perfect squares. The word difference, right? We would know that is already giving you that is indicating subtraction. Okay? So there's a hint right there in the word. As we go through this, so yesterday we did GCF. Today we're doing dots. Something to always keep in mind is to always check the remaining factored parts to determine if they can be factored again. So a little hint to the activity, the rest of the problems in this sheet. So how to write your final factored answer. This kind of goes hand in hand. On page 8 of our packet, we talked about day 5, multiplying polynomials continued. And we talked about conjugates, where they had the same term but opposite operations. One was adding and one was subtracting. So that's actually how we're going to write our final factor term. So if you look down here, first and foremost, always see if the expression has a GCF. And then you want to divide that out first and leave the GCF outside the final answer, outside the parentheses of the final answer. So number 2, if we could just take a look at this right here. If there is a GCF or if there was not, right, you take that out first. The remaining expression in the parentheses will be broken into two parts using the following setup. So you create two sets of parentheses. One set will be adding, so we'll have the addition sign in the middle. And the second set will be subtraction and will have the subtraction symbols. So if I'm looking at this part, that means I'm setting it up like this, two backs of parentheses. One will have subtraction, one will have addition. Okay, now it doesn't matter the order. If you start with your addition and then you want to do your second one subtraction, totally fine. And then you take the square root of both terms in the expression. You place the square root of the terms in the parentheses created in the correct position. So same position as original expression. Right, so I'm going to move down and we're going to try this out. How come I can't? Okay, here we go. All right, so we are going to look at, let's do number 1, and let's do number 3. Okay, so 1 and 3 we're going to look at together. So number 1, so now I'm presented with this expression, and they're asking me to factor. The first thing I'm going to say to myself is, well, do they have a GCF? Is there a greatest common factor between y squared and 16? No. Okay, so I don't have to worry about that. Let me go down my list. Can I do difference of two squares, dots? Well, what are the requirements? I have to have two terms, and they have to be perfect squares. Okay, 16 is a perfect square. Y squared is a perfect squared. And the operation between them is subtraction. So number 1 does satisfy the requirements. So then if I'm going to do that, I'm going to start setting up my parentheses. okay? One is going to be addition, and one's going to be subtraction. Again, I'm just going to make this one a little larger. Again, it doesn't matter which one you put first, okay? So now I'm going to focus just on the y squared. So y squared, if I were to take the square root of it, well, basically I'm just saying y and y, right? And then I look at 16, the square root of 16 is 4. So I put a 4 and a 4. Okay, and please be mindful, it's taking the place when you are putting them into your parentheses. The location is important. So my green corresponded with y squared because that was the first term in the expression. And my blue corresponds with 16, which is my second term in the expression. Again, if you always want to check, you can multiply this out. Now, this is the part that I was talking about that kind of goes along with page 8 in our packet. So if you girls want to reference back that page, that would be really helpful during this lesson especially. So again, if you're looking at conjugates, it's basically if they are the same terms but different sides, you could just multiply the first terms together. So I can multiply y and y, and I would get y squared. We said that the operation, I don't want green, hold on, sorry, I'm just trying to change my color for you girls. The operation between them would be subtraction. And then if I'm looking at my outer term, the second terms, 4 and 4, I just multiply them together, I square them, and that would give me 16. So this answer goes right back to what we originally had. Okay? So that was number 1. If we're looking at number 3, you want to start with asking yourself, the question is, well, does this have a GCF? Does 3x squared and 27 have a GCF? Well, yeah, the GCF here would be 3. So I could first divide each term by 3, find the GCF, and I would have 3, and then 3x squared divided by 3 would give me x squared, minus 27 divided by 3 would give me 9. So if I'm looking at this again, look at my parentheses, x squared minus 9, can I factor that again? Can I use GCF? No, they don't have any more common factors, but I could use dots because it satisfies the requirements. 2 perfect squares, and the operation between them is subtraction. So again, I would set up my parentheses, one with addition, one with subtraction. I did it backwards each time just to show you that it doesn't matter. I would bring down the 3 because I didn't touch it. And then the square root of x squared would be x. The square root of 9 would be 3. Okay? And if I want to check, I would multiply these two together, and I would end up with x squared minus 9. And then I would multiply it by 3, and I would get 3x squared minus 27, which takes me back to the original one that we already started with. Sorry, I did a bad job with differentiating, but I'll do some highlighting so you could just see where I'm getting these things from. Okay? All right, girls, thank you.